Okie dokie. Here we go. Factoring polynomials, more difficult ones, okay? This is with that leading coefficient with a number in front. So where we are now, or where you should be now, is being able to comfortably factor something that looks like this, right? Where we have a number 1 in the front. Because that means that you know the first term has to be an x and an x, or whatever your variable is, right? If it's an n squared, then it's n and n. And then we look at this last number and we look at all the possible ways that we can get 10 through a multiplication of two numbers. And then we look at these pairs and see which one of those will give us the middle. You can see that a plus 7 would be from a plus 5 and a plus 2. Obviously, we can make those a little more complicated when we start throwing negatives in there. But what we're looking at today are even more complicated ones that have a number in front of that x squared. Here's the first one. Let's look at this one and see if we can work through it, okay? So I've mentioned several times in class that the first thing you want to do is see if you can actually remove what they call a common factor. I'm hoping that in this case you can see that you remove a 3. If you remove a 3, you end up with x squared minus 9x minus 10. And this one is significantly easier to solve, okay? So we're going to look at going 3, and then it's going to be x and x, right? This is like the ones that we looked at the other day. The one that I just showed you, it has a number 1 in front of the x squared. So we look at the last number, we can see it's 10 times 1 or 5 times 2. Those are the only choices. Which one of these will give me a negative 9, right? Hopefully you can see that it would be a minus 10 and a plus 1. And you're done. Notice the 3 stays there. It needs to stay there. This is the fully factored form of this polynomial or trinomial right there. Okay? Let's now look at a different one. Again, look to see if you can actually divide these things by any number. Can you reduce this trinomial? Now you can see that obviously everything goes into 2, but maybe there's a bigger one. I'm thinking 6 might work. So what I'm going to do is I'm going to check to see if 6 actually works. Does 6 go into 114? Absolutely. Does 6 go into 84? Absolutely. So if I divide it by 6, what I'm going to end up having, let's use these numbers here, 114 divided by 6 gave me 19. So that means that, sorry, let's do the first one. This would be 3x squared plus 19x, and then 84 divided by 6 gave me 14, so that's minus 14. There you go. Make sure that you don't have anything else in here that can actually be divided by, and it looks to me like that's about right, okay? So what's the next step? Well, this is the process, okay? Now, what are all your choices here, right? You could have a 3x here and an x here. You could have a 7 and a 2. You could have 3x and an x, and it could be 2 and 7. You could have 3x and x, and it could be 14 and 1. You could have 3x and x, and it could be 1 and 14. In this case, you don't have tons of choices, but you do have a few, right? Now you could go through them all and try them all, or well, that's going to be more difficult when sometimes you're going to have 12, 15 choices here, right? We only have 4, so we can figure it out. But let's look at a method. I don't have a method, a name for this. We're going to look at decomposition. But what I'd like you to think about is this. If we put brackets down here like this, you know that these first two numbers have to multiply to give you the 3, and these last two numbers have to multiply to give you the 14. So it's the 3 and the 14 that are of importance to us. And this is how we're going to look at it. I'm going to ask you what two numbers multiply to give you 3. You're going to say either 1 and 3 or 3 and 1. I'm just going to go 1 and 3. I'll put them on top of each other. 14. I have two choices. It could be 7 and 2, or it could be 14 and 1. So let's do 2 and 7 here. Let's go 2 and 7. So what I do is I cross multiply, and I say, okay, that gives me a 7 and that gives me a 6. Can I get a 19 from 6 and 7? And what you're going to see is that you can't. It doesn't work. So we're going to try 1 and 3, and let's mix it around. That one doesn't work. So let's try 7 and 2. So now that gives me 21. That gives me 2. can I get a positive 19 from 21 and 2? The answer would be yes. It would be a plus 21 and a minus 2, which means that if you get rid of these cross multiplications here, that means that these are your factors with the 1x, no sign, so it's a plus 2. And this negative, or plus 7, sorry, this negative came from here, so that needs to be negative, and there you have your other factor. So it's x plus 7 and 3x minus 2. Don't forget the 6 in front, and this would be your final answer from this trinomial. Okay? I guess the only way to ensure that we got this is to try another one, right? So let's have a look at another one. 2x squared plus 11x plus 12. Well, nothing that I can factor out of that, so we're going to start right away. Let's look if we can make some sense out of this. So the numbers that multiply to give me 2, 1 and 2. Let's start. 12. Well, let's go 6 and 2. All right. Well, that gives me 12 and that gives me 2. I can't get an 11. So we switch these. 1, 2, 2, 6. That gives me 4. That gives me 6. I can't get an 11. So it's definitely not 2 and 6. Let's try 1, 2. Let's go 3 and 2. Sorry, 3 and 4. So that gives me 6, that gives me 4. I can't get 12. Still not working for me. So let's go 1, 2. How about we split these around? 4, 3. Well, that gives me 8. That gives me 3. Can I get an 11? Can I get an 11? Yes, you can, right? If they are both positive. If they are both positive, these are both positive, and then you have 1x plus 4 and 2x plus 3. So that would break down into x plus 4 and 2x plus 3. If you wanted to check your answers, you can always FOIL these out, right? 2x squared, that gives you plus 12, 8x, 3x gives you 11x, and you're done. Okay, we're going to look at another way called decomposition very shortly. Right now, though, I'm going to keep doing this for a few more to see if we can get the idea of this method here. Okay, I don't really have a name for it, but it is what it is. So here we go. Now we got a few more options here in the front, right? It could be 4 and 1, or it could be 2 and 2. I just have a tendency to do 2 and 2. Why don't you guys try and finish this one off? Pause it for a sec, give it a go. And I will finish it in 3, 2, 1. Here we go. So 15, 5 and 3. Give it a shot. Boom, boom. 10 and 6. Oh my God, look right away. I can get a 4 from 10 and 6. That would mean the 10 has to be positive, the 6 has to be negative. The 6 came from here, so we make the 3 negative. That's going to be 2x plus 5, 2x minus 3. Right away, we've got it dialed, worked out in the first one. This is what happens quite often. It happens right on the get-go, especially if you do a few of these, you start getting the hang of it, and you start seeing maybe potentially what some of the answers could be, and you use educated guesses, right? But the idea is that you have a process. If it doesn't work with the first one, you switch it around, and you keep going until you got the idea. Let's have a look at another one here. This again does not have any common factors, so I can't reduce it at all. But what I can do is what we just did, right? Look at the first number. I'm going to go 4 and 3, just because. Could be 6 and 2, could be 12 and 1, whatever. 3 and 1. Let's look again. Oh man, it's going to work right away. I don't want to do it right away. Let's do this way. 1 and 3. So that gives me 12 and that gives me 3. I can't get a 5. So what do? I switch these around. Let's switch them around. It was 1 and 3. Let's make it 3 and 1. Now, 9 and 4. Can I get a plus 5? Can I get a plus 5? That would be plus 9 and minus 4. The minus 4 comes from here, so this is negative. That one's positive. 4x plus 3, 3x minus 1. 4x plus 3, 3x minus 1. Okay? I think we got a couple more here to have a look at. Give that one a shot straight off the bat. See what you can do with that. See what you can do with that. Any common factors? I'd say no. 12, 12, 20. That's going to be interesting. 12 is one of those weird ones because it has lots of factors. Chances are we're probably not going to get it right on the first go, but let's have a quick look. We'll try. Let's go 6 and 2. Let's go 4 and 3. I have no idea, okay? This gives me 8. That gives me 18, almost. 26, not going to work. So let's try 6, 2. Let's try 3, 4. That gives me 6. That gives me 24. Still not going to happen. So the 3, 4 won't work, okay? Well, let's try something else. How about 6 and 2? Well, I can kind of see that those aren't going to work either, right? 12 and 12 gives me, so having the 6, 2 at the front isn't working. So what we do is we try something else, right? Let's try 4 and 3 now. Let's go 6 and 2. That gives me 18. That gives me 8. I can't get a 26. Well, let's keep going then. Hold on a sec here. Let me fill this over. Let's go 4, 3, and 2, 6. That gives me 6 and 24. Still not going to get a 25. Well, the 4, 3 might work, but I'm going to have to try something else here as well. How about a 3 and a 4? I'm kind of seeing it now, because that gives me a 16. That gives me a 9. I can get a negative 25 from 16 and 9 if they are both negative. And if those are both negative, it means that these need to be both negative. That would be 4x minus 3 and 3x minus 4. So 4x minus 3 and 3x minus 4. Minus 3 minus 4 give you a plus 12, so that one actually works out pretty good. A good example of how you have to go through a bunch of different things, right? 1, 2, 3, 4, 5, 6. I tried 6 before I finally got the right answer. Okay? Now that's not a problem, it just takes a little bit of time is all. Now I'd like you to try this one. Please look at it. Identify anything that you might be able to take out first. And absolutely, there is 2. And it becomes 2x squared plus 5x minus 3. Okay? Now some of you might be able to see what's going to work already. There are easier ways to do these. Well, not easier, but quicker ways. You only have one choice for 2, meaning one pair that multiply to give you 2. It's a prime number, so it's got to be 2 and a 1, right? So you know that when you factor this, you know it's going to be a 2x and an x, right? And your only choices for 3 are 1 and 3. So we start figuring it out and we have a look. Well, if you put a 3 and a 1 here, something might work, but you know, we got to figure it out. This one's actually a little trickier because there's a couple different possibilities. So let's sort this out here. Let's do the factors of 2. 1 and 2. Factors of 3. 3 and 1. So that gives me 6. That gives me 1. Can I get a plus 5 from 6 and 1? Absolutely. Plus 6 minus 1. This minus 1 comes from here. That comes from here. So you've actually got them done right now. 1x plus 3. 2x minus 1. Okay? I think there's one last one. One last one. Let's see how you guys fare with this. I'll get ready, give it a shot. 1 and 5 are my only choices. Let's go 4 and 1. That gives me 20. That gives me 1. I can't get a 1 here. So switch it around. A 1 and a 4. That gives you a 5. That gives you a 4. Can you get a negative 1? Yes. Minus 5 plus 4. Plus 4 here. Minus 5 here. So your answer would be x minus 1 and 5x plus 4. Okay, so this is how we are factoring these polynomials, ladies and gentlemen, okay? The polynomials that have a leading coefficient greater than 1. Okay, here are the answers. Hope that makes some sense. I'll try and post another video showing a different method for some of you if you think it might help. But please try and get these dialed. It's going to help you a lot in this year and especially next year.